Okay, so for our topic, we did graphing 2D linear inequalities.
The 2D linear inequalities, they resemble linear equations, but they have a greater than or equal or less than sign instead of an equal sign. And if for the y equals negative 3x minus 2 is a linear equation, but the y greater than negative 3x minus 2 is a linear inequality. And if it's greater than or less than, then it's a dash line. But if it's greater than or equal to or less than or equal to, then it's a solid line when you graph. And you shade the area where the solution is true.
Okay, so for our first example, we're going to do it on the board.
Okay, so it's x plus 4y. Can you make that bigger?
You're fine. They can see you.
I know, I need this.
Oh, you need that. It's right there.
4y greater than 2.
2. So you're gonna make it into slope-intercept form, so you move the x over. And then divide by 4. And then to graph it. And we're just going to use a scale of 1. So you graph the slope intercept, which is 1/2, and then you do the slope. So you go down 1 over 1, 2, 3, 4, and you connect your lines. And since it doesn't have an equal to sign, it's a dashed line. And then to figure out where you shade, you plug in the point 0, 0 to the original equation. So it's 0 plus 4 times 0 is greater than 2. So 0 is greater than 2, which is not true. So you shade above it. And that's your graph.
We're not there yet. We have a few more samples before.
Not bad.
So for the next example, we have 3x plus y is greater than negative 8. Like you said, you have to put it into slope-intercept form. So it's y is greater than negative 3x minus 8. And you start at negative 8 and go down 3 over 1. And then you connect your line and plug in the point 0, 0 like we did in the last one. And that's true, so you shade in the 0, 0 region.
Make sure it's a dash line.
Yeah, it should be a dash line because it's
The next example is x plus 4y is less than or equal to 2. So you move the x over and divide by 4. Plug it 1/2, then down 1 over 1, 2, 3. Yeah, but it's from a different sign. So since it's less than or equal to, it's a solid line. plug in 0, 0 again. If 0 is less than or equal to 2, so usually down here.
Can we come over here and help me? Yeah, since it's longer. Or I can come from there, so it's easy. Okay, so for the last one, we have our application. So if Alexis started a local restaurant and wants to monitor costs for the employees versus revenue, which is what you bring in, versus maximum hours that one can work, how does she find her profit ranked if her cost is Y is less than X minus 2, her revenue is Y is less than 3X minus 6, and her maximum hours is 3.5. So you start with your graph. Okay. Can you go back to that so I can see it? And so you're going to do all of these equations like we did the other one. So like for the first one, you would start at -2. Maybe up 1 over 1. Up 1 over 1. Which this graph is kind of not right, but you connect that one. And since it's
Since it's just a less than sign, then you have a dashed line.
and then the second one is y is less than 3x minus 6. So you start at -6 and go up 3 over 1, up 3 over 1, up 3 over 1. And then if her maximum hours are 3.5, then you come over to 3.5 on the graph, and you have a line up and down. This one would be -2 since it's not greater than or equal to or less than or equal to. And then the area where all three overlap is your shaded region. So that will tell her what she needs.
Okay, questions for this team?